All right, today we're going to dive into something super fundamental, network topologies. Think of them like the architectural blueprints, the master plan, that dictates how all our digital devices actually connect and talk to each other.
So, you ever walk into an office or even just look at your own home setup and wonder how all those computers, printers, and gadgets are all connected? How do they work together so seamlessly? It's easy to just assume it works, right? But behind it all, there's a specific plan, a layout that makes everything possible.
Well, the answer to that question is something called network topology. And it's not just about where the physical cables go, though that's part of it. It's also the logical flow, kind of like the rules of the road for your data. It's the whole shebang, the complete picture of how a network is built and how it actually operates.
So here's what we're going to cover. We'll start with the blueprint idea. Then we'll jump into three classic designs: the bus, the star, and the mesh. We'll even look at some hybrids and other variations, and then wrap it all up with how you actually choose the right design for the job.
Okay, first up, the bus topology. This is probably one of the most simple, straightforward ways you can build a network. It's all based on one single shared line.
The core idea here is incredibly simple. Just imagine one long main street. All the houses, or in our case all the computers, are connected directly to that one street. That main street is what we call the backbone cable, and it carries all the traffic for the entire network.
So how does it actually work? Well, you've got that central backbone cable, and then you have smaller drop cables that connect each computer to it. And at the very ends of the main cable, you have these little things called terminators. They're super important. They stop the signal from literally bouncing back and creating a mess. But here's the key thing to understand. When one computer sends out a message, it's just broadcast down the entire cable. That means every single workstation sees that message.
And that leads to a pretty clear trade-off, right? On one hand, it's cheap and super easy to set up. You need the least amount of cable. But it has a massive weakness. If that main backbone cable breaks anywhere, the entire network goes down. Poof, gone. And on top of that, since every computer sees all the data flying by, security is, well, it's not great, to put it mildly.
So, those big problems with the bus layout, especially that single point of failure, led engineers to come up with a better way. Enter the star topology. This design is all about revolving around a central point to make things way more reliable.
So instead of everyone sharing one big cable in a star network, there's a central device. It used to be called a hub, but now it's almost always a switch. And every single device, I mean your computer, the printer, the server, everything, gets its own dedicated cable that plugs directly into that central switch.
Now, this setup is so much easier to manage. Think about it. If the cable to your computer fails, it doesn't affect anybody else. You can add a new computer or take one away without shutting the whole network down. But there's a new single point of failure, isn't there? The whole thing now depends on that central switch. If that goes down, the whole network is dead in the water. Plus, it's a bit more expensive because you have to buy the switch and a lot more cable.
And you know what? That balance of pros and cons is exactly why the star topology became the #1 choice for most networks you see today. For modern LANs, like the Ethernet in your office or home, it just hits the sweet spot. It fixes that huge, catastrophic problem of the bus network, where one little cable break kills everything, but it's still way, way cheaper and easier to manage than our next topology, the mesh. That's why it's the go-to for pretty much everyone.
But what if good enough isn't good enough? What if you need the absolute maximum, can't ever fail level of reliability? Well, for that, we have to talk about the mesh topology. This is the most resilient, most fault-tolerant design you can possibly imagine, but as you might guess, that resilience comes at a very steep price.
The whole idea behind mesh is total, absolute connection. In a full mesh network, every single device is directly connected to every other device. Just try to picture that. It's like a crazy complex spider's web, where there are tons of different paths to get from any one point to any other.
So, the big payoff for all that complexity? Insane reliability. If one cable fails, who cares? The data just instantly finds another way to get where it's going. It's not a big deal at all. The flip side, of course, is that the cost and complexity are astronomical. The sheer amount of cabling you need is just mind-boggling. And trying to set up and manage all those connections, it's a huge, huge job.
Okay, so in the real world, things aren't always so black and white. You don't have to just pick one of these blueprints and stick with it. You can actually mix and match them to create what we call hybrid topologies, which are designed for very specific situations.
Here's a really easy way to think about it. Imagine you've got an office building set up with a nice modern star network.
But then, out in the attached warehouse, you have an older, simple bus network running the machinery. Well, if you connect those two networks together, what you've created is a single, larger, hybrid network. You can pretty much combine any of these types to build a custom solution.
And there are a few other variations worth knowing about. There's the ring topology, where all the devices are connected in a circle and data goes around in one direction. You used to see this in older networks. Then you've got point-to-point, which is as simple as it gets, just a direct link connecting two things, like two buildings. And there's point-to-multipoint, which is kind of like your Wi-Fi router at home, one sender broadcasting out to a bunch of different receivers.
So after looking at all these different blueprints, the bus, the star, the mesh, and all the others, it all comes down to one big question. How on earth do you choose the right one for the job?
Well, this table really lays it all out, doesn't it? It's a classic trade-off. You've got bus, which is low cost, low complexity, but also low reliability. Then you've got mesh on the other end, high cost, high complexity, but it gives you that rock-solid high reliability. And star, it's sitting right there in the middle, a nice balance of all three. Your choice really just comes down to your budget and how much you absolutely cannot afford for your network to go down. And that really gets to the heart of why you'd ever choose something like mesh. You're paying all that money and dealing with all that complexity for one single killer feature. Having so many paths that your data is basically guaranteed to get through no matter what happens.
So at the end of the day, there's no single best topology. It just doesn't exist. There's only the right one for what you're trying to do. And that choice is always going to be a careful balance between cost, how reliable it needs to be, and how big you need it to be.
And that kind of leaves us with one last thing to think about. Our world is getting more and more connected, right? With the Internet of Things, with AI, we're connecting billions of new devices. Our need for speed and reliability is just exploding. So what do the network blueprints of tomorrow look like? What new designs are we going to have to invent to handle all that? It's a pretty cool question to chew on. Thanks for joining me.